Greetings from the set of Metro and More at Metropolitan Community College, serving more than 50,000 students with over 120 programs at our 8 locations in the daytime, evening, weekends, or online. Hi again, everybody. I'm Kent Pavelka for Metro and More. Today at Metro's Fort Omaha campus with a tour of the Fab Lab at Metropolitan Community College. With me are information technology instructors Hugh Shuett and Jamie Bridgham. And we want to get familiarized with the Fab Lab. Good to have you with us.
Good to be here.
Maybe chat just a minute or two about yourselves. You guys are intimately involved in this. You run it, and I think our viewers are probably interested in a little bit about your backgrounds. You were telling us, Hugh, you've been here, what, 15
Yeah,
years
this year
now?
it'll be 15 years.
Yeah.
As full-time faculty.
Has the beard been here that long, or?
Almost. I've had it since '96.
Very good.
So it's pretty close.
15 years in information
Yes.
technology.
Yes.
Right. And Jamie, how long have you, you're 10 years, a little longer?
Yep, 20-year anniversary this year as a full-time faculty.
Yeah.
A little bit longer. I was also an administrator over in IT too, so.
The Fab Lab is under the umbrella of information technology, right?
Sort of, it's more under workforce innovation, but the classes and those things fit under the information technology.
Yeah. What did you all do before you got into education here at Metropolitan Community College?
I was in the military. I fixed vehicles. I ran MIS departments. All kinds of different things.
Yeah.
I had a fine art degree and have been an artist since I was 16 years old. And I'm a lot older than that now. And then I went into IT because I needed to make a living. And so I did IT. I ran the email systems and the college servers for a few years, and then worked out in the electronic imaging area, all kinds of stuff.
Well, I think most of our viewers, or a lot of our viewers, have heard of the Fab Lab, but haven't seen it, and we're going to show you the Fab Lab today. But tell us about it. What is the Fab Lab?
It's actually short for Fabrication Laboratory, and it's a local lab, but there's a whole worldwide group of them, and it's all an MIT concept. Neil Gershenfeld from MIT came up with the concept, and he actually had an NSF grant to actually take the computers and then make them in ultimately to that Star Trek replicator that takes atoms and creates something from the atom. Well, this is just one step on the way to get there. So we take these really powerful computers, and rather than just surf the web or watch YouTube videos, we actually go and hook them up to these equipment, and then we make stuff. So it's local manufacturing. It's actually manufacturing at the personal level.
But there's a network, right? I mean, that's a key
Yes.
part of this.
There's
You're connected with MIT, right?
Right, and there's about 40 labs in America, and there's about 400 labs throughout the world right now. When we got our lab and started it up, we were about the 145th in the world, and that was only a year ago.
But that interconnectivity is a key component here of this whole thing, because you can talk and collaborate, correct?
It is. We have the ability, and you'll see it later, we have the ability to, with a video conference, hook up and talk to any other lab that's on there. And we all log into MIT servers. And so if there's an issue, we don't understand how to do one thing on a machine, or they don't, or we're talking about getting new machines, we can have a conversation with someone around the world about that stuff.
So Fab Lab is an abbreviation for Fabrication Lab.
Correct.
For what students? Who uses the Fab Lab?
Everyone. One of our missions is to make everybody realize that it's not just an IT thing, it's not just an engineering thing, and it's the science department. We make the couplers so that they can do their science experiments. It's the photography lab so that they can do output in engraving or boxes or their books. It can be the architecture for buildings. It just goes on and on.
And so how long has the Fab Lab been in existence?
About December 20th of 2013 is when we had our first class.
We just had our birthday.
And before the Fab Lab, was there just a a vacuum, and I mean these service
They didn't exist.
You couldn't touch this.
Right. We didn't have the equipment. We didn't have the collaboration. We didn't even have the thought process of doing something like this.
So, and are you two the only folks that are involved as far as instructors are
We
concerned?
just brought in a third instructor,
Uh-huh.
Chris Chisholm. He is working with us on the electronics and helping getting the guitars and some of the stuff up to par that way.
Yeah.
We also have 4 AmeriCorps work studies. So we have students that come in here and spend about 20 hours a week learning the equipment, helping other students, you know, teaching them, doing projects, all kinds of stuff.
Yeah. And this is you're going to see what the facility is here in a minute, but it's going to be outdated pretty soon. I mean, it's going to be, you're moving, and we'll talk about that, but
Right.
You've got stuff jam-packed in here right now, don't
Yeah.
you?
It gets standing room only.
Right. And they said, you know, can you find a place for it? Yeah, bring it in. We'll find a place.
And right
and
now,
so it's packed.
You're utilizing it for how many students? I mean, I'm just trying to get a sense of how it's used.
We had 125 students that they could count in the last reporting on the grants. So that's a lot considering this was supposed to be a test case. We were never supposed to. We already have 2 full-time credit classes, and we have multiple non-credits. So we get a lot of people, we touch a lot of lives, and that's not including all of the people that we support sort of secondhand.
Sure.
They come in and do their final project. They'll come, people from UNL that come in and work on projects with us and that kind of stuff.
Very cool. Now you can see in the background we have a lot to show you, and we're going to do that. Hugh Shewitt, Jamie Bridgham with me here at the Fab Lab at Metropolitan Community College. We'll be back with the tour on Metro and More right after this. We are back on Metro and More, and today we're giving you a tour of Metropolitan Community College's Fab Lab at the Fort Omaha campus. Hugh Shewitt is with us, Jamie Bridgham, and we want to show you, before we actually show you the equipment that produces some of the things that are made, Jamie, show us what this is and how it comes to be. I mean, with what we use for the technology.
Okay. Over here in the beginning, we've got examples of 3D equipment. Hugh's going to show you later that we have a couple of different types of equipment we have that are 3D. We have ABS plastic. This would be used by the science department to do structures, and you can tell it's really, really light. This is our more expensive polymer 3D. And this is a lot heavier. You can sort of tell, feel that one, and then feel this.
Oh yeah, yeah, significantly.
It's almost 100 times the cost. So we obviously prototype in the lighter, and then we go to the heavier when we want to do something really detailed.
In a little bit, Hugh will show us what
actual
equipment we use to
yeah.
produce this.
This also was created on the polymer, and it shows how it can print color on the outside of the object as it's printing the physical object itself. And it gets all of its color from the polymer or from the ABS or the paint you put on it. But it will paint using HP technologies as it's printing.
Okay.
And that would be an example of what you would see in an architecture class. This is another version of that. So it's a building, it's printing inside and out. You can see even the rooms, see how they've got the lighting and the landscapes inside of them. And then a machine or a engine block.
Yes.
This is Hugh's favorite. Me as an artist, I'm not that thrilled by it, but I think it is really, the detail is beautiful.
Very intricate, yeah.
And it's a great way to show mechanical students what something's going to look like. This is something that Hugh created for Kendra, who is our physics teacher. And she goes and does experiments which are using hot air balloons that they send up stuff. And she's connecting a sensor to a probe that's like the sensitized polymer or acrylic. And she needed a light, tight connector. So one piece comes in here and one comes in here, and it's normally black. so no light gets through. So it's only the light going through this that's getting to the sensor that's being measured. But it's an example of what we use for science. This is an example of 3D scanning. We have both a large scanner that Hugh's going to show you, and we also have an iPad scanner that you just go in and the person spins in front of you. You scan a picture, it goes up to the cloud puts it together, and then we can print it. This is the same person.
When you say print it, this
On a
doesn't
3D
look,
printer.
this piece here has been printed,
Yep, on a 3D printer.
and that's how it's fabricated.
Yep, it's just, in this case, it's extruded out of the head of
Printed
a
on
print
what
head.
kind of material?
It just is printed on itself. It just starts, it lays out a base, and then it keeps going up and just up and up and up and up. This case, it goes and starts at the bottom, and it's laying down layers of the polymer, just laying down the binder, and then he'll explain the process.
Okay, let's move down this way
Yeah.
so we can get everything in that we've got on the table.
This is an example for photography. This is a true working photographic pinhole camera, totally 3D printed and then put together. I made it, so I made it and printed, and this shows you it does work.
Wow.
Took pictures of the next piece. But as you can, so these are pictures of the guitars.
Yes.
Yeah, but this is all the different pieces are printed and then put together.
Very cool.
Now this is Hugh's joy, the guitar class. It is a physics credit, so it shows you how something totally creative and cool can be turned into a science, applied science, that actually can enthuse people. They start with a blank that we get from another college. And then they go in and they sand it, they do all of this is a student that is Van Gogh inspired, obviously.
Yeah.
And he's gone in and finished the whole product. By the time they're done, it will have all of the innards, all of the electronics, and they plug them into amps and play, and if they know how to play. That's sort of a problem sometimes. This gives you an example of another piece of equipment that Hugh's going to show you, the laser and the different stuff you can do. We do work with entrepreneurs, so this is an example of an entrepreneur that comes in and does engraving on leather. So he does a lot of experimentation, and our entrepreneurs that come in and help us then also talk to our students and
About their
work
experience.
through, and how do you prototype? How do you go in and get into business and some of those things? He's been great working on projects with us for that. This is an example or a piece, again, the laser can't cut into metal, but it can oven-baked paint. So this was a project Hugh did in collaboration with another college for the rocket stove. He'll explain that when he gets to that. But this shows you how you can use metal and do different things with it.
Yeah.
This gives you more of an artistic twist. Again, it's a photograph that's been engraved. This was from Estes Park, so it was a photograph I took. And then you can almost feel.
Sure can.
And that's the part that the texture just is so cool on it.
Yes.
Same type of piece. This is taking a photograph, dividing it into parts, lasering it, and then one of the things that people think is we're always using the big tools. We use hand tools for all of the pieces. So this is layer of acrylic that then has been put into a channel into the frame. So we used all of the hand tools and the regular tools to make that.
You didn't make the
Almost
bottle,
disaster.
did you?
No, this we engraved.
Yeah.
Again, we can't cut the aluminum. Not on this. He's going to show you something called milling that can do the aluminum. This we just engrave the paint off, and then we go there. Last thing I really want to show you is this is more of an example of how we go into the high schools. This was a project by Northwest High School. Their Upward Bound came in, and their goal was to research Victorian house. They knew they were going to make it a Victorian dollhouse, but they had to research the colors. They had to tell me what colors were authentic for that period, and then they had to find the picture of them, tell me the price, where I could go shop for them. They had to figure out how would they market the dollhouses. So you've got a full, and then they put them all together. So all of these, it takes 13 boards to cut them in the laser. And as you can tell inside,
Wow.
you've got the rooms. We threw in a little bit of furniture. They didn't get quite that far because it was a little bit shorter time period than they thought, but it was a good project for them.
Oh, yeah.
But talk about, we had 4 groups and we had people sitting on the floor, underneath tables, everywhere because the room was so cramped.
Well, there's a great rundown on what the Fab Lab can do, and we're going to take a look. He's going to rejoin us momentarily, and we're going to take a look at the equipment that produces these examples. Okay, Hugh, now Jamie was talking about printing this.
Right.
This is the machine that prints this. Printing meaning producing it.
Right,
Yeah.
exactly. This is additive manufacturing.
So show us what this does.
So really what happens is this goes in here, it comes out of there, I
Yeah,
should say.
yeah.
Anyways, this starts with this really fine polymer, and it puts a layer down and puts a binding agent on it. It's like a really lightweight super glue. And it also puts color on. So this thing goes back and forth, and then this goes back and forth and puts a binding agent down, puts the color down if it needs it. So like on this one, it put color down.
And it does it in layers, right?
It does. And so what happens is it puts a layer down, puts color on it, puts a binding agent on, puts another layer down, puts more color, more binding agent, and eventually it's just building this thing up and up and up. And then when it gets all done, then you have this big pile of white dust.
Wow.
And so then what you have to do is you take this vacuum unit and you vacuum all the excess out, and it goes back into its chamber, and then you take it over behind you as a cleaning unit where we actually finish cleaning it. And the last thing we have to do is put it's like a super glue, a harder one that gives it its very vibrant colors on the color stuff and the very hard outer shell on this.
So this is what printing these objects is about with with these machines.
Right, exactly. And it is just like taking and cutting a snowflake in a piece of paper and doing it 500 times and gluing each one of them together. Pretty soon you get a snowflake about this thick.
Yeah.
And that's what's going on here.
What are these?
Okay, so these are also 3D printers, but these are ABS plastic ones. So like Jamie said earlier, this is done with ABS plastic. And on this one, it's pretty easy to see all the layers.
Yes, it is.
And on this one, you can see all the layers too.
How long does it take to print an object like this?
It's like watching grass grow.
Is it?
Yeah, this takes about 7 hours to print.
That's not bad. That's amazing.
Unless you're watching it.
Yeah, that's right.
But so what happens with this, it works just like a hot glue gun.
This is the material.
This is ABS plastic, and so it goes through this little hot tip here. It gets really hot, and it actually melts it, and then it puts it on this platform where it needs to, and then it moves, just keeps moving around, keeps forcing more material, and just like if you were taking a hot glue gun and kept squeezing it and moving it around.
And you end up with this.
Right.
Very cool.
Because it's computer controlled. So these aren't necessarily hollow inside. You can see that there's a honeycomb in there.
Yes, there is.
And that's to provide it a little bit of structure. You can't just have a hollow environment and have no strength. You got to have something in there. So they all have a little bit of something in.
Very, very cool.
And then over here, we have our 3D laser scanner. So then what the whole process would be, let's say we want to reverse engineer a gear. We got a gear, it's got a broken tooth on it. We put it in here. Okay, so that's not a gear, but we can put a gear in there and reverse engineer it. So we scan it, we get the digital image of it, and in our digital software, we fix that gear, and then we go over there and print it out. And if we get everything exactly right and it looks like it fits right, then we can go to different printers. Or we can go to our CNC mill and actually cut a metal gear from that same design then.
And was this object made in this?
No, this is just so that we can scan stuff. And the reason that this is good to practice
this
with
is the scanner, yeah.
is because it's a laser scanner, and lasers are absorbed by darker colors. So the black and the green get absorbed, and you end up having holes in your design. It gives a chance to actually learn about the software a bit more so that you can actually fix the design and modify it to whatever you need.
So you got your laser scanner and printers. How about we go to the other end of the building here,
Okay.
of the room, and take a look at the rest of the stuff. Kent Pavelka, Jamie Bridgham, Hugh Schuett. We're back at the Fab Lab at Metropolitan Community College on Metro and more. We've moved to the other end of the Fab Lab as it is now, soon to change.
Right, it will.
A lot bigger facility, but talk about this part of the Fab Lab and this equipment.
This is our desktop CNC machine. And with it, you can actually create all kinds of very precise items.
CNC.
Yeah, computer numerical code. And we actually teach the great big Haas machines down at the South Campus in precision machining, but this is a very small version of it. So we can create simple things like that, stuff like this.
But precision is the key word
Exactly,
with this.
and it's not fast. It's no faster than the 3D printer, but it's extremely precise. So if you create something like this, even though it's aluminum, we can do that in here.
Wow.
And it's the logic behind what they do down at South in their precision machining of this machine is the same.
This is amazing. This says Hugh, not Kent, though. There's a problem.
That's not a problem in my mind.
Gosh, it just occurs to me, the cost of these things must be enormous.
It can add up. Like, for example, all the equipment we have in this lab here is about $150,000 worth.
Not as much as I thought.
No, well, the new lab, which will be 10 times the size of this, we're looking at probably, I don't know, a couple $1 million worth of equipment at least.
What did students do? What did the community do before the advent of this to try to create these kinds of things and
Well,
have this kind of experience?
You'd have to go to university and take all the coursework and take a class, or go to a machine shop and pay someone a lot of money to create something like this. You know, you just couldn't, these were all created inside. Inside here. You couldn't just actually come, and create something of your own. And the cool part about this whole thing is, when you're an entrepreneur and you have an idea, we have all this space.
Yeah.
And we're getting more space, which means we will have a space for fit and finish, where if you want to powder coat something when you get done, if you want to use the electronics and create a circuit board to run something that you create with metal or with wood or with the lasers, all kinds of stuff. So it's really, really expanding.
Very cool. Let's move over to the corner over here.
Okay.
I'll put these down, and then we've got some vinyls, and then what's this over here, Hugh?
This is our vinyl cutter. And so the cool thing about a vinyl cutter is, yeah, you can do regular signs. You can do, we have t-shirt vinyl, so you can do stuff on t-shirts. And we can do stickers, and just like the other one that Jamie showed you. Rather than take the anodization off, we actually just put a sticker on top. Now the cool thing is, we have all this vinyl here that from down below is regular vinyl. Up here is t-shirt vinyl. And we can also cut soft copper with a sticky back on it, so we can actually cut circuit boards on this too.
Very cool.
And do surface mounted chips.
Then you've got Big Red here.
Right, and that's the name we kind of call it. It's actually a laser, 80-watt laser. It can cut up stuff up to as thick as 3/4 inch pine. We can do engravings that are as detailed as little bitty letters on there.
Wow.
And again, this is what Jamie showed you. It doesn't mess with the metal. It takes off the paint or the anodization.
And the wood, is that wood? It looks like wood. It's not.
Yeah.
Is it wood?
And what happened was, we can actually engrave dog tags because it's anodized aluminum. And so I created this jig so we could have a place to set all the dog tags. And I used the laser to do it. Well, when you engrave something, it's never really a perfectly smooth surface. And so the dog tags didn't fit quite right. So then I went and I made the second version. And with this one, I actually used the desktop CNC machine, cut these out very precisely, and then used the laser to cut the holes and everything else. So they really do fit well. I don't have any dog tags laying around. But this was a much better version. But this also shows you that when you build something, you're not always just going to use one machine. You might use 2 or 3 machines to come up with your final product that you need. And so it's a good example of it.
We talked about how all this, the Fab Lab, is incorporated in the academics at Metropolitan Community College, but you
Right.
also talked about entrepreneurs utilizing it.
Right.
Give us an example of someone out in the community who may, have an idea, but not a lot of experience or understanding of this process. What would they do to investigate using the Fab Lab?
Well, they have to give either Jamie or I a call or an email, set up a time, they come get a tour, and they see, what kind of equipment you got, how they might be able to use it. Like, for example, one of our partners is Barry Doon from Domacat, and he does leather. So he's been up here using the laser, and he's been creating wallets, he's been creating purses, he's been working with engraving, and you saw a couple of the examples earlier today. But the cool thing is, it's a small business, he's getting some access to a very expensive piece of equipment,
Yes.
and he doesn't have to buy it. And his contribution back to the college is not only helping us with learning how to do leather work, but he helps students with that kind of information too.
But take another step in that example. If he decides this is a great product, I want to sell these on a more mass production.
Right. This gives him the
proposition.
ability to do the prototype and come up with the design and perfect it. And then let's say he wants to do a mass producing. Well, at that point, he might have to go somewhere else because
Right.
we're not set up to do mass production. We're set up to come up with that initial prototype. But maybe he needs that so that he can get more funding so that then he can mass produce them.
Otherwise, he'd have been stuck and never would have gotten to that point.
Been doing it all by hand and maybe never gotten to the point where he has some of the products that this can do in a very small amount of time that he can't do even, on his own.
Yeah. To talk about what I'll call a monitor over here. What is that? And then we're going to wrap it up in a minute. But that's an important.
Yeah, that
Piece there.
actually is our connection to all the other Fab Labs around the world.
Oh, that's it. Okay.
Yeah, and
So the screen we're looking at right now, what are those windows? I mean,
those are conferencing units. So that's the video picture of all the other Fab Labs around the world, and you'll find in the mornings that you'll have Europe on there, and in the afternoon it'll be just America, but in the evenings then it'll be Singapore and over in the Asia area, they come online.
So I mean, do you control who you're looking at there, or is it just pop up?
We can actually control which one we focus on, but it's either you're online or you're not.
Gotcha.
So you can't focus on someone that's not online.
So the one blank over there, that's an
They shut their-
availability there.
Well, and they actually shut their camera off, or shut the lights off, but the camera's still running, so you just can't see anything.
So is there audio that goes with that?
Yeah, and typically we all have our microphones muted so that it's not just white noise. And then what happens is if someone wants to talk to someone else, you unmute your microphone, everyone has their volume up, you start talking, and then you get to actually hear someone, and so then everyone kind of pays attention and unmutes the microphone, and then you start having a conversation.
So is there some sort of key that you know what they're doing? So, I mean, if you're interested in some specific information of some sort, you can
Not
get it?
yet.
Yeah.
I'm
That's
part of
the
the,
part that we want.
right, and
The students are always asking, what are they doing
Yeah.
there?
right. Well, and I'm part of the leadership on the United States Fab Lab network. And so one of the tasks that I've got is actually to come up with a database of all the other Fab Labs that are here, all the experts, what equipment they have, who to contact, and all kinds of stuff like that, so that when someone does come here, they can go to this database and say, I need to figure out that more, there's the expert, and then go talk to them.
Try to get that done by 2017, would you?
It'll be done before that.
Let's take a break. We'll be back to wrap it up from the Fab Lab at Metropolitan Community College on Metro and more right after this break. Exciting things happening at the Fab Lab at Metropolitan Community College. Jamie Bridgham, Hugh Hewitt, thanks so much for the tour. Now we see what we've been hearing about, and excitement ahead too with the expansion in the new buildings and such. Thanks so much.
Yep.
And thank you for being with us on Metro and more.
At Metropolitan Community College, you can start where you left off. Sometimes things happen in life that can put college on hold. We want you to know those credits that you've earned in the past can be transferred to a degree program that will put you on a new career path. Best of all, you can do it all online on your schedule, and it's just a third the cost of a big university. To get started, call a return specialist at 402-457-2270. Metropolitan Community College.